Hi everyone, today's video is about illustration of limit theorems, and basically here the focus is going to be on the 8 fundamental theorems about limits, and I will only give you one example for each, so this is going to be a quick lesson. Let's go to the first one. We call this the limit of identity function theorem, and it says here that the limit of identity function theorem states that if f of x equals x, then the limit of f of x as x approaches a value c is simply c. All right, so that's the mathematical definition of that. This one. So for example, we have the limit of x as x approaches -8. Guess what's the answer to this one? That is correct. It's just equal to -8. Right. Let's go to the second theorem. We call this the limit of a constant function, and here it states that if a function f of x is a constant value k, then its limit at any point c is simply that k, where k is a constant and does not depend on x. So for example, here the limit of 14 as x approaches 5, then that means it will just be equal to that number 14. Easy, right? Let's go to the third theorem. Here we call this constant multiple rule for limits. And here it states that the limit of a function multiplied by a constant is equal to that constant multiplied by the limit of the function. So that's the mathematical definition of that. Here, two things you have to remember. There is an f of x and there's a k. So for example, if f of x is equal to x minus 7, find the limit of 2 times f of x. So let's use the equivalent of that here. So which means I'm going to put 2 outside of that, and then I will evaluate the f of x as x approaches 3. So this is just um, so 2 times. So as x approaches 3, this is 3 minus 7, which is equal to -4. So that means I will just multiply that by -4, and the answer is going to be -8. All right. Let's go to the next one. Here, limit of the sum of two function. Um, so here it states that the limit of the sum of two function is equal to the sum of their individual limits. So for example, we have two functions here, f of x and g of x, and we want to find the limit of the sum of those two as x approaches 1. So what we will do is we will evaluate them individually as x approaches -1. So 2 times -1 plus 1, this is -2 plus 1, which is equal to -1. And then the g of x is equal to -1 minus 3, which is equal to -4. Now here it states that we can simply add the two, and that gives us -5. There you go. One variation of this is limit of difference of two functions. So you know how it is. The operation is division. I mean, subtraction. All right, let's go to the next one, which is the limit of the product of two functions. And here it states that the limit of the product of two functions is equal to the product of their individual limit, provided that the limit of those two functions exists. So for example, again, we have, this is, I think, the same functions that we had earlier. So this is negative. Let's evaluate that again. This is -2 plus 1, which is equal to -1. And then here, -1 minus 3. What is happening? Oh no. Let's go back there. So -1 minus 3 equals -4. And according to the theorem, we can simply multiply the two to find the limit. So the answer is +4. Alrighty. Let's go to the next one. So the limit of the quotient of two functions, and here it says that the limit of the quotient of two functions is equal to the quotient of their individual limits, provided that the denominator is not equal to zero. We know what's going to happen if the denominator is equal to zero, right? The entire function is going to be, or the result is going to be undefined. So let's say here we have f of x, and that's 3x, and we have a g of x, which is x plus 2. Let's solve the limit individually by substituting that 2 to this 3x. That gives us 6. Here, this is 2 plus 2, which is equal to 4. And applying the limit, this is just equal to 6 over 4. And I believe we can simplify that, which is equivalent to 3 over 2. Or if you want to convert that into mixed number, or yeah, mixed number, that will be fine. But 3 over 2 is acceptable. Let's go to the next one. And this is the limit of the nth power of a function. And here it states that the limit of a function raised to the power of n is equal to the limit of the function raised to the power of n. So for any positive integer n, provided that the limit of the function exists. Let's have an example. Our f of x here is 5 minus x. We need to find the limit of f of x raised to 4. So let's evaluate first that 5 minus x, which is 5 minus 3. And that gives us 2. And according to the limit to the theorem, we can do this, 2 raised to 4. So we all know what that means. It's not 2 times 4, okay? It's 2 times 2, which is 4, times 2, which is 8. That's 2 raised to 3 now. 2 raised to 4, multiply 8 by 2, that gives us 16. All right? So 2 times 2 times 2 times 2, and that gives us 16. And that is our answer. Right, so I believe we are now down to the last theorem, and here we call this the limit of the nth root theorem, or nth root of a function rather. Here it states that the limit of nth root of a function is equal to the nth root of the limit of a function, provided that the limit exists and is valid for real numbers. So you see the mathematical definition of that. There are two conditions here. If n is even, the limit of f of x as x approaches c must be a non-negative number, meaning should be positive or 0. Because since the real square roots of a negative numbers do not exist. You gotta take note of that. So if n is odd, then the root is defined for both positive and negative numbers. Okay, so let me give you an example. Okay, so here n is odd, so meaning it depends on f of x. Um, what will be the answer to this? So if you look at the definition, the mathematical definition, what we can do again is just evaluate this f of x if x equals 6, or if as x approaches 6. So negative 6 squared plus 9. Now be careful when solving this one. Some of you might be typing, if you're using a calculator, you type negative 6 squared plus 9, or you put a parenthesis, you're in close parenthesis rather, it will become negative 6. So you don't do that. Remember that x is 6, not negative 6. So it's very important that that negative is outside the parentheses. That's what I'm trying to say. So 6 squared is 36. That'll be negative 36 now because of the negative sign outside, plus 9. That's negative 27. So that means what's the cube root of negative 27? Now according to the second condition, it can be both positive or negative. So since this is negative 27, our cube root of that is negative 3. Okay?